In today's class, let me discuss two more problems in multiple integrals. The first one is evaluate double integral of ax dy dx divided by x squared plus y squared, square root of that, and it is the limit is from 2 minus x squared 0 to 1. So this is the problem, and here you see that we have to go for the change of order of integration and then evaluate. In this particular problem, that is in the given problem, the first integration has to be carried out with respect to y and then with respect to x. But the problem given to us is that we have to change the order of integration and then evaluate. For that, we have to determine the domain on which this particular integral has been defined. Now, see what is the, let me write, see this is y is equal to x. Since you are integrating with respect to y here, it is y is equal to x to y is equal to 2 minus x squared, which implies this is y squared is equal to 2 minus x squared. This implies x squared plus y squared is equal to 2, that is y is equal to x 2 x squared plus y squared is equal to x squared plus y squared is equal to 2. So this is the given limit with respect to x. With respect to y is equal to x to this much. If you closely observe this, you will find that y is equal to x is a line, whereas this x squared plus y squared is equal to 2 is a circle with the origin as center, and the radius is equal to square root of 2. And what is the limit of x? X is equal to 0 to x is equal to 1. So with these as limits, let me draw the diagram to find out which is the domain over which this particular integral is to be evaluated by changing the order of integration. Okay, now I will draw here. Say since this is a circle, let me draw the circle first and put it like this. Now this is your origin, and that this is y is equal to x. This is your y is equal to x line, and this is x squared plus y squared is equal to 2. The radius of the circle is root 2 0, and this is 0 root 2. Now that, see here it is very clear that from the limits defined here, y is equal to square root of 2 minus x squared, it is a positive quantity. That means your limit lies only in the positive quadrant. Positive quadrant, y lies in the positive quadrant means above this x is equal to x axis, and therefore here it is not defined here. So your integration lies only here, that is your domain of integration lies only in the first quadrant. And moreover, here you see that x is equal to 0 is here on the y axis, x is equal to 0, and it travels to the right and it goes up to 1 Therefore you see that our domain of integration lies only in the first quadrant. Now let us find out what is this P. What is the P? Is the point of intersection. P is point of intersection of y is equal to x and x squared plus y squared is equal to 2. So that if that particular point P is known, our domain is completely defined and we can go for the integration by changing the order of integration. Okay, now so you see that y is equal to x means wherever y comes you put it as x. So what is that you will get here? 2x squared is equal to 2, x squared is equal to 1, x is equal to plus or minus 1. I will take x is equal to plus 1 because it is given that x is equal to 0 to x is equal to 1. That means it lies only on the, it is totally confirmed that it lies only on the first quadrant, and you see that this is the point P is. Because if you put x is equal to 1, here y is equal to x means y is equal to 1. So what is this point of intersection? P1, 1. Now our domain is domain of integration. So I'll write here domain of integration is OPQ. I'll write it as what? OPQ. What is that? It is 0, 0 and it is 1, 1 and it is 0, 2. This is your O origin and this is your P and this is your Q. So this is the domain enclosed in this particular by these points O, P, Q. It is enclosing a space over which we are going to integrate. So this is now, we are clear about the domain of integration. Now we have to go for change of order of integration and then integrate. Okay. So let me write here. So I will rub off this space. For want of space, I will rub off everything. So what is that I will do? See. Now you see that here. So what is that I must do now? So let I be equal to, it is nothing but double integral of, now I must do x dx dy divided by x squared plus y squared. Now I must do the integration. Okay. So this is what I do. Now here this is the integral, and this integral cannot be carried over or it cannot be determined on the domain OPQ as such. So what I do is I drop a perpendicular like this, and this is your P dash, and this P dash is your 0, 1. P dash is 0, 1. I draw the perpendicular and it cuts this x-axis, y-axis at 0, 1. Now I have got two regions. So what is the region now? OPQ is equal to OPP dash plus PP dash Q. So integral of the double integral of this will be equal to double integral of on OPP dash and double integral on PP dash Q. Now this is what I should do. So if you call this as your I1 and if you call this as I2, your I on this will be equal to I1 plus I2. This is what I am going to do now. Okay. Now, so this I will write it here. So keep this in your mind. Let me write here. Now what is that I will write here? See, it is your OPQ is equal to double integral of OPP dash plus double integral of it is P dash and Q. You call this as your I1 and you call this as your I2. Now let me come to my I1. What is my I1? I1 you simply write it as it is. That is, it is x dx dy divided by x squared plus y squared square root of this. It is square root of this. Now, here you see that now you have to fix up the limit. You have to fix up the limit first with respect to x and then with respect to y. Now come to this OPP dash. OPP dash x, you draw a line horizontal to x-axis, draw a line horizontal to y-axis. So that when they intersect at a point, and that is the smallest element of area that you get, and it has to be extended over by integration. It can be extended, that is by integration we can find for the complete domain by keeping this the small bit of area, extend it to over or integrate it, you will get with respect to this particular integrand. That you must understand. Now you see that when you take the x limit, x on the y-axis is 0 and you draw a line parallel to x-axis, it will go and dash against a point on the line y is equal to x. That means it will start, your x limit will start from 0 on the y-axis, and it will go and dash against a point on y is equal to x line. Therefore, your limit for x is equal to 0 to y. Now, having fixed the limit for this x, let me go for y. What is your y? Y will start from 0 or from this. This means what? You will start from the bottom of this line, which is nothing but what? Y is equal to 0. That is x-axis. Y is equal to 0 or at the origin. Climb up and come to, it can go to a maximum distance up to 1. P dash is 0, 1. So it can go up to 1. So it is your 0 to 1. Now you see that this integral has to be evaluated. Now, here I will write something and explain after then why I have written like that. And that art of integration, that art of doing that particular part comes by practice and also using our knowledge in various branches of mathematics. Okay. Now, I will write here it is 0 to 1, and I will write this as it is, see, 0 to y, and here I will write it as d of x squared plus y squared whole to the power of half. Keep this in a bracket, and then you write it as dy. Now you see that something I have written here. Now if you take the differential of this, this is half into x squared plus y squared 1 minus half into 2x into dx. If you take the differential of this, this will be the 1. With respect to y, it will be 0 because I am taking only the differential with respect to x. Now you see that this 2 and this 2 will go cancel, and it will give you what? X into dx. Bring this to the denominator, so you'll get x squared plus y squared square root of this. So you see that this particular part is present here. Can you see this here? So this particular part is present. So for that particular part, I have written d of x squared plus y squared whole to the power of half, which is very much correct. Are you able to understand? Now that this particular part looks like a d of x. So what is the integral of d of x? It is simply equal to x. So this particular part requires, as I told you, an experience and also knowledge on various branches of mathematics and also some intelligence. I should definitely say that you require some intelligence there. So you see that this is what we get. So immediately what I will do here is that, so I will rub off this. Now what is that you will get here now? So in this place, so using the integration, what is that you will get here? So this is equal to, it is 0 to 1, and you write it as x squared plus y squared whole to the power of half, and this has the limit, it is 0 to y, and then integrate with respect to y. Now this is 0 to 1. Be careful in doing the problem. So wherever x comes, you put it as y. So what is that you will get? Y squared plus y squared is 2y squared. Square root of that minus first limit minus the second, upper limit minus the lower limit. So then put x is equal to 0. So you will get, it is square root of y squared, and again it has to be integrated with respect to y. So what is that you will get here? It is 0 to 1. Square root of y squared is y. So 2y minus y, and this has to be integrated with respect to y. Now you can take this conveniently, this square root of 2 minus 1 outside. So you will be left with only simply dy. So you take this root 2 minus 1 outside because it's y is common. So take this y common outside. So you will be left with root 2 minus 1, which is a constant which can be pulled out of the integral sign. And you see that root of 2 minus 1, 0 to 1, y dy. So this is equal to root of 2 minus 1 y squared by 2, and this has to be, this has a limit from 0 to 1. You apply the first limit only because second limit gives you 0. If you apply the first limit, this is half. So this is half into root 2 minus 1. So this is your I1. So what is your I1 value? I will write here. So your I1 is equal to half into root 2 minus 1. So this is my first integral. So my first integration is done. by changing the order of integration and going through the process of integration. So I am able to get this. Now I must go for finding the integral value of the second integral I2, find it out, add with the first I1, then you get the answer. Now let me do the second one. What is my I2? Now what is my I2 now? I2 is very easy to do because I2 is integration and everything is the same except for the limit. So you see that your I2, now write this I2 is equal to, again I will write it as x dx divided by, since I have explained everything to you, I am writing it again with some sort of this thing, brackets and everything to explain better, but you should know how this how I am going to integrate this. That has already been explained. So I will put it in such a way that it is, I can immediately write the result. Now you see that here, let me come to, this is your what? I2 is on what? It is on PP dash Q. It is on PP dash Q. Now let us take here x limit and y limit I must fix. So draw horizontal line to x-axis, draw horizontal line to y-axis. Now you have to fix the limit for x. So x again starts from, in this area, in this domain, it starts from 0 and it goes and dashes against a point on the curve, namely x squared plus y squared is equal to 2, which is a circle. So you see that it starts from 0 on the y-axis and it goes and dashes against a point on the circle. What is that circle? X squared plus y squared is equal to 2. So this implies that x squared is equal to 2 minus y squared. So x is equal to plus or minus, it is 2 minus y squared. But as I told you, I will not take this negative because we are dealing only with the integration, that is the problem only on the first quadrant, which is positive. So you see that x is equal to plus 2 minus y squared. So it is going up to what? 2 minus y squared, square root of that. And coming to y limit, y is equal to y on the PP dash, which is the area PP dash Q. So on PP dash, it starts from PP dash, or any point on PP dash is parallel to x-axis, and any point in this will be equal to what? 1. That is, y value is 1 throughout here. So it starts from 1 and it can go up to a maximum of, what is that? The circle ends here. So it can go up to a maximum of root 2. So it can go up to root. So your y limit is 1 to root 2 and your x limit is 0 to square root of 2 minus y square, and the integrand I have written here. Now, as I explained while doing I1, I will take the liberty, or I will take, with your permission, I will write straight away this integral as it is x squared plus y squared whole to the power of half, and the limit is from what? It is 0 to 2 minus y squared and into dy. See, this part has been already explained while doing that I1. So I take it for granted that you have understood and it has been written here now. Now you apply now of the limits. You apply the limits now. So this is equal to, I'll write it here. So 0 to 2. Now you first apply the limits. First limit, if we put x is equal to so much, it is 2 minus y squared. X squared, x is 2 minus y square root of that. So you square it plus y squared. This must be kept in a square root because this is half, minus, apply the second limit, x is equal to 0 means it is y squared square root of that into dy. So this will be equal to what? It is 1 to square root of 2. It is minus y squared plus y squared. So you are left with only root 2 minus, it is square root of y squared is y. So this is what you get as dy. Now this is equal to, I will simply write here square root of 2 into dy. The integration is nothing but square root of y, square root of 2 into y, and this is what? Y squared by 2, and you take the limit from 1 to root 2. 1. That means what? Wherever y comes, you put root 2. Now y is equal to root 2 means root 2 into root 2 is 2. Minus y squared is root 2 whole squared is 2. So it is 2 by 2. Keep this in a bracket. Apply the lower limit. When you put y is equal to 1, you will get 2 minus, when you put y is equal to 1, you get half. So open the bracket. So this is 2 by 2 is 1, 2 minus 1 is 1, minus, take it inside. So what is that you'll get? Minus root 2 plus, minus into minus will make it as plus, and you get to be what? It is half. So this will be equal to what? It is 3 by 2 minus root 2. So you see that it is here you put here now. So you see that here you will get root 2y, put root 2 into root 2 is 2, and when you put here 2 by 2 is 1 minus, then it is root 2 is here. When you put 1, it is root 2, it is minus half, minus into minus is plus. So 1 plus half is 3 by 2 minus root 2. So what is that you get? So this is your I2. This is your, so what is your I2? I2 is 3 by 2 minus root 2. 3 by 2 minus root 2. Now what is the answer that you will get now? So your I1, I will be equal to what? So your I will be equal to I1 plus I2. So I1 is what? Your half of root 2 minus half plus 3 by 2 minus root 2. This is what you will get. So what is the answer that you will get? So you see that it is 3 by 2, it is half root 2 minus half root. See, this is half root 2, this is minus 1 root 2. So you will get minus half root 2. And 3 by 2 take away minus half, take away half. 3 by 2 take away half is plus 1. So this is equal to 1 minus half of root 2, or you can write it as 1 by 1 root 2. So this is your answer. So here you see that this is how this problem is done. It is or change of order of integration, and then here small things that you must know is the art of the method of integrating that particular place. So if you know that, it will be easy for you to complete this problem. So this is all about your first problem. Now let me pose on to the next problem. Next problem is slightly not difficult, but still it requires a lot of understanding over the subject. So let me do that for you. So you see that here you are asked to, I'll just brief the problem as given in the book. It is, you are asked to find x squared plus y squared into dx dy. See, find integral over d of square root of x squared plus y squared dx dy. D is a region, it is a domain in xy plane. It is a domain xy plane, a parallelogram formed by A01, B10, C31 and D22. So these 4 points when plotted in the xy plane will give you a parallelogram, and that this parallelogram will be transformed, or it will be transferred to another plane UV plane. It will be transferred to a UV plane by giving a transformation u is equal to x plus y and v is equal to x minus 2y. Giving this transformation, you should evaluate this particular integral. So this particular integral, you are not supposed to integrate and get the value with respect to the domain here in the xy plane. This one, you are asked to go for a transformation. Using the transformation, u is equal to x plus y and v is equal to x minus 2y, and then integrate in the domain which you obtain in the UV plane. So here we are going to give a transformation and do the problem. Now, before that, you must know, you draw this, say I'll draw everything here. So you see that here, this is your xy plane. Here it is like this, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now you see that Here I write 0 1. Where is your 0 1? 0 1 is here. So this is your 0 A. B is 1 0. So this is your B. So draw like that. Okay. Then C is 3 1. Your C is here. Your 3 1 is here. C 3 1. And D is D 2 2. So 2 2 is, it is 1 2. So 2 2. So 2 2. It is 3 1. So the graph I will draw again with the equal spacing, then only you will get 1 2 3 4. 1 2 3 4. It is well, this is, let us see, 0 1 is here, 1 0 is here, then your 3 1 is here, 3 1, and your 2 2 is here. Okay, it is a parallelogram. So this is A, B, C, D. So you see that this is a parallelogram that is drawn in XY plane. This is 1 2 3 4, like that 1 2 3 4. So you are going to give a transformation to this UV plane. See, let me draw this UV plane. Now, let me write U is equal to X plus Y. U, when you put A, see, for A, if you are going to give U of A, that means what will be U in, if that A point is taken? What will you get here now? This is the transformation. What is your A here? A is 0 1. So if you give 0 here and 1 here, you see that you will get 1. So U is 1. Now I want V. See, what is that corresponding? See, this is your U. U is your X coordinate here, and V is your Y coordinate here. And for this A is what? 0 1. So if it is 0 1, your U coordinate is got by adding 0 and 1. And your V coordinate is what? So your V coordinate of V will be equal to, how is it related? V is equal to X minus 2Y. So X is equal to 0 here. Minus 1 into 2 is minus 2. So what is your, this one? So for this correspondingly in UV plane, in the UV plane, it is in UV plane, A is A dash, which is nothing but 1 minus 2. So what is that? Here you take the point A. If you give a transformation like this, then the corresponding point that you will get here is your 1 minus 2, taking this. See, I have written here. I have explained to you. UA giving the transformation is, you give, what is giving? The X plus Y. Here X is 0, Y is 1, so it is 1. For V it is what? X is 0, Y is minus 2 into 1, so you get this. Likewise, I will write B dash is for B. What is your B dash here? Your B dash is, B is 1 0. So your U coordinate will be, put X is equal to 1, Y is equal to 0. So your B dash is 1. So U value is 1 here. Coming to this V, it is U, X is 1 and Y is 0. So again it is 1 1. So your B dash, see what is that? B dash for B 1 0. So when it is B is 1 0, B dash is your 1 1. And likewise, what is your C dash for C? What is your C here? 3 1. So if it is 3, See, 3 plus 1, it is 4. So your x coordinate or u coordinate is 4. And for v coordinate, it is 3 minus 2, it is 1. See, it is 3. For x you put 3 and it is minus 2. So 3 minus 2 is 1. So you see that for c dash is 4 1. The corresponding c in the xy plane is 3 1. And d dash, it is d is what? Your d is 2 2. So when you put 2 here, 2 plus 2 is 4. And when you give 2, it is 2. Then it is what? It is minus 2. See, it is 2. When you give 2 into 2 minus 2. Minus 2 plus 2 minus 2 minus 4. This is minus 4. Minus 4. So it is minus 2. So for 2 plus 2 is, see, for 2 what we will take? 2 plus 2 is, it is u is 2 plus 2 is 4. For this it is minus 4, it is 2, so it is minus 2. So you see that we have got this a minus 1, b dash, c dash and d. So if you give a transformation, you see that it goes up to a maximum of, I'll write here, 1, 2, 3, 4. 1, 2, 3, 4. See, you may not get the correct figure, but just try to understand the principle behind of doing this, you will get. So it is what? 1, 2, like that. So you see that here what is your a dash? 1 minus 2. See, 1, where is 1 here? 1 minus 2. So this is your a dash. A dash. 1 minus 2. See, 1 minus 2. Then next is what? B dash is 1 1. So B dash is 1 1 here. B dash is 1 1. Then C dash is 4 1. So your 4 1 is here. And D dash is 4 minus 2. So 4 minus 2 here. So you see that so you see that a dash, so we have got a dash 1 minus 2, b dash 1 1, c dash 4 1, d dash 4 minus 2. So a dash is 1 minus 2, b dash is 1 1, c dash is 4 1 and d dash is 4 minus 2. So this xy plane parallelogram has transformed into square, that is it is transformed to a dash, b dash, c dash in the uv plane. Now that you have to do the integration of this double integral, not over this but only over this where your variable is uv. I hope that you are able to understand up to this. Now let us, what is that we have to do now? So here you see that you are giving two transformations. It is not a single transformation. U transformation given, u change of u is given, change of v is also given. Therefore, in the change of du dv, you require what is called a Jacobian has to be found. What is a Jacobian here? It is dou x by dou u, dou x by dou v and dou y by dou x, dou y by dou u and dou y by dou v. So this has to be found. You have to find the value of this Jacobian in order to get the, because of the transfer, you are giving two transformations. Because you are giving two transformations here, we require what is called the Jacobian, and with using this Jacobian, we will be able to get the transformed integral so that we can evaluate. Now, what is x here? Now you have to solve this. What is that? U is equal to x plus y, and what is that? V is equal to 2x minus y. Now you subtract here. So u minus v, I will write here u minus v, y minus this is what, 3y. So your y will be equal to u minus v by 3. Okay, Now you see that your y is equal to 3 minus v, u minus v by 3. So you substitute here. So what is that you will get? U is equal to x plus, it is u minus v by 3. So this implies x is equal to u minus u by 3 plus v by 3. Take it to the other side. That is, what is that you will get? Here x is equal to u minus this u by 3, then this is v by 3. So what is that you will get? 3u minus this is 2u plus v by 3. So what is that you will get? So you see that you will get 2u plus v. 2u plus v. So you see that you solve these two. That is, u is equal to x plus y, and this, when you subtract, this will become plus, so 3y. So 3y will be equal to u minus v, so y is equal to u minus v by 3. Now substitute here. Now you will get, what is that you will get? U is equal to x plus your y is what? It is u by 3 minus v by 3. So take it to the left hand side. What is that you will get? X is equal to u minus u by 3, and this will become plus v by 3. So what is your LCM? 3. So 3u minus u is 2. 2u plus v by 3. So this is the transaction. So what is that you are having now? So you are having this u, I will write here, see. So what is that you are having? X is equal to, I will write here. So your x is equal to 2u by 3 plus v by 3. What is that? V by 3. And your y is equal to what? U by 3 minus v by 3. So this is the relation that I have got between x and uv. That means what? X is a function of uv and y is a function of uv. Now since you are giving a transformation, this dx dy will be transformed into du dy dv with this Jacobian. Okay, this is your Jacobian. Now I'll write here what is the value of this. So what do you get here now? So dou u by, now j is equal to dou u by dou x. What is dou x by dou u? Dou x by dou u is, see, dou x by dou u, partially differentiate this with respect to u. So this will be taken as a constant, and this will be 2 by 3. And dou x by dou v, so this, treat this as a constant, partially differentiate with respect to v, so you will get 1 by 3. 1 by 3. And now you will partially differentiate with respect to u, you will get 1 by 3. And partially differentiate with respect to v, you will get minus 1 by 3. So this is what you get. So this will be equal to what? It is minus 2 by 9 minus 1 by 9 plus 1 by 9. It is minus 2 by 9. It is then this is minus 1 by 9. So minus 3 by 9, that is equal to minus 1 by 3. Now we want the absolute value of Jacobian. So this is equal to 1 by 3. So what is your j? So I have got the Jacobian as 1 by 3. So now that, what is that I will write here, so you are able to understand. See, it is x plus y whole square. You are going to find x plus y whole square dx dy. Now I will be equal to, what's your x plus y? So u is equal to x plus y. So your x plus y whole square will be equal to your u square. So this is your u square into Jacobian dou u du dv. So what is that you will get here now? So you will get this to be, your answer will be equal to, so this is equal to, what is that? It is u square, this is 1 by 3 into du dv. Now this is double integral of u square, you take this 1 by 3 outside, and du dv. Now you see that you have got here uv, that is a dash. See, this is a domain you have got a dash, b dash, c dash and d dash. Your a dash, I have given you the points here, coordinates 4 1, this is 4 minus 2, and this is, now you see that if you draw like this, then you see that I am going to determine. So here x will start on this. What is the value of this x here? It starts at 1, see, x is equal to 1 on this line, and it will go up to 4. So X means here u. I mean here your u value, u is 1 here. See, you wherever this u, it is taking the value 1, and wherever on this it is taking the value 4. So it goes from u is equal to 1 to 4. Are you clear with this now? V takes the value, it is minus 2 here. So it takes the value minus 2 and it goes, see, it is here minus 2. Wherever this V, it is minus 2 only. So you see that it goes up to 1. So your minus 2 to 1. So it goes up to, see, minus 2 here and it goes up to 1. Whereas your this one, X value, it starts at 1 and it can go up to 4. So your u value is from 1 to 4 and v value is from minus 1 to 1. So what is that you get here? It is minus 1 by 3 minus 2 to 1, and it is u cubed by 3, and it goes from 1 to 4 and it is dv. So this one, 64 minus 1. See, put x is equal, u is equal to 4. 64 minus 1 into dv. So 64 minus 1 is 63. Take that outside, divided by 3. And it is from what? 2 to 1. And it is your dv. Okay, here I will write. Sorry, here I think 1 by 9. I think I will write it here 1 by 9. I will write it here now. 1 by 9. I have taken this 3 outside. 1 by 9. And it will be now, you see that 4 4s are 16, 64 minus 1, lower limit, into dv. So what is that you will get here now? So you will get this to be 1 by 9. It is minus 2 to 1. It is 63 into dv. Take that 63 outside. 63 by 9 minus 2 into dv. That is equal to 21 by 3. Or 7 times of, it is v minus 2 to 1. Say 7 into, it is 1, minus of minus 2 is plus 2. So 7 into 3, that is equal to 21. So what is the integral of this? So what is that you have got here? So the value of this multiple integral on giving a transformation is 2, 1. So what is the final result that we can write this here? So this double integral d on plus x plus y square dy square in new plane uv is 21. Answer. So okay.